Okay, so till now we have talked about RDD, right? And RDD means resilient distributed data set. And we know when we talk about RDD, everything in Spark behind the scene is RDD. We know this thing, right? But when we coded in RDD, we know few things that even just to the word count program, you need to know some kind of programming, right? For example, you need to split it, you need to do some tupling, you need to uh, do some like you need to go for each, you need to go for reduce by key. And somewhere I felt like that RDD gives you a lot of control. Obviously it gives you a lot of control, but here there are two things. You are telling the system how to do it, right? Let's say if you are an expert and I tell you, no, do this thing in this way, even you know the better way, you need to do this thing in this way. There is no optimization, right? So Spark researchers think about it and they say, guys, RDD is very low level coding. If you are excellent coder, go for RDD, no issues, right? If you know how to do performance tuning, how to write a better code, classic code, you can go for RDD. But if you want us to if you want us to Spark to performance tune the thing, then don't tell us how to do it. Just tell us what to do, right? So that's where the evolution of structured API comes in picture, right? So let me write it here. So RDD is what to do and how to do, right? We will go to very low level. And you know this thing that we did the splitting, we did the mapping, we did the flat mapping, then we created some tuples, pair tuples, then we go for reduce by key. We are telling system what to do. Then what structured APIs are, and I'll cover structured APIs. Just tell the system how to do. You want to count? Okay, just say, guys, give me the count of the words, and it will figure out the way in some beautiful way, in more performance tuned way to do the things, right? And that's where it will come in picture. Behind the scene, there is no doubt about it, everything is RDD. So even though you write code into structured APIs, everything behind the scene will be converted to RDDs, everything will be converted to DAG, lineage, everything. But how that DAG is created, it's not you are deciding it, it's some optimizer deciding you on your behalf. Okay, let me jump here. Something like this. So when we work with RDD, do we see any optimizer here? No. But when we see some APIs, structured APIs, there is one optimizer sitting between here and Spark core, which is converting your code into RDD. This is the most important feature I can see. That there are a lot of features. There are a lot of features which will make your programming easy. Since you do not need to tell the system now what to do it. You just need to tell how to do it. You do not need to write low-level coding. A lot of things can be there. The benefits of structured APIs, but this is the best benefit. What I feel, like the programs are now Spark will tune the program on your behalf. Okay. So now let's talk about what structured APIs are, right? So structured APIs, I will be covering SQL in a lot of detail. So for now, there are two structured APIs. The first structured API is DataFrame. The second is Dataset. When we talk about DataFrame is nothing new. The guys who know Python in Pandas, this DataFrame evolved from there. Same thing like this. So what DataFrame says, guys, DataFrame gives the schema view to the data basically. So what it says, let me go here, and when we go to the order.txt, right? So in order.txt, we have 4 columns, right? And we don't know what these columns are. We don't know what these columns are. But if I give some schema, let's say if I know that this is order ID, right? This is order underscore ID. This is your date. This is your cust ID, right? And this is your order status. And then what, this make more sense to us, right? That okay, first column is order ID, second column is date, third column is cust ID, fourth column is order status. This exactly the work which I did manually, exactly the same thing DataFrame is doing for you guys. So it will give some schema to your data. So you already have the data, you can give some schema to it, right? There are so many ways you can assign a schema. We will jump to them later, but this is how it works. Okay. So if what is written here, DataFrame gives a schema view to the data. Basically, it's an abstraction. In DataFrame, view of the data is organized as column with column name and type info. So schema means what? Whenever we talk about a schema means two things. The first is name of the column. The second is type of the column. So when we talk about, when we say that DataFrame gives some schema to the columns, right? It will say that DataFrame give two things to the columns. One is type and other is name. Okay. And now this is not a rocket science to understand that DataFrame will treat your data the same way you treat the data in the relational database. So now here what we can see, we have table with 4 columns and let's say 561 rows with this data. This is how the DataFrame treats your data. Okay. Now coming to datasets, right? So you know the benefit of dataset, right? The dataset will give some schema to your data and you're happy enough. But the problem with dataset is that it won't give you too much flexibility. Okay, before I go to the dataset, let me tell you why people still like RDD, right? Why people still like RDD. RDD is all about low level coding. RDD is all about low level coding, right? Low level coding means whenever you code the program your way, let's say there are two things. Either you can order pizza from Pizza Hut, or you can make your dough, you can put your toppings, which give you more control. Obviously, when you make pizza at home, right? So RDD is all about that. So you will have better control of the things, what and how you want to do it, right? And RDDs, obviously we know, are statically typed. So we cannot, and RDDs are statically typed means we cannot, so it means that if there's some error, it will give error on the compile time, right? The only problem with RDD was this particular optimizer was not there because it is the base, right? With DataFrame, what it came, that okay, you have some optimizer came in picture, but with some drawbacks. What are the drawbacks? That DataFrames will not give you error at the compile time. They will give you error at the runtime. So you may write something, it will get compiled, on the runtime it may fail. This is the biggest drawback, right? So what people thought about, guys, can we have something with the benefit of both? With the benefit of Spark optimizer and benefit of low level more control coding. Then they come up with a solution called datasets. So what datasets are? Datasets are extension of DataFrames. Basically, it has two different APIs. First is, it is very strongly typed. It means it will give you error at the compile time, right? Sorry. And RDDs were untyped, like generic type. I'll come to that later. Datasets are by default collection of strong type JVM objects, unlike DataFrames. Okay. So now, whenever we go for DataFrame, how we see behind the scene, everything is the dataset, right? Behind the scene, everything is a dataset. So what DataFrame actually is, it is data set of row object. Am I making sense? So when we talk about data frame in reality is a data set of row object. And when we talk about row object means it is generic type. Any type can be here, right? I will show you here quickly. So one second. So here somewhere I have that code for you guys. Yeah, this one. So when we see here, so what I said, that data frame is a data set of row objects, right? This is clear, right? Data frame is a data set of row object. But what exactly is a row? What exactly is a row, right? So row is a generic type. Let me do it for you in practicality. So I'll go here. I will open a terminal quickly and I'll say spark-shell. Okay, I'm just showing you what row means because I think the confusion which will create here, okay, what is the difference between data frame and data set? So we know data frame is data set of row objects, and in reality what data set is now, so let it get open. And what data set is? So data set in reality is a strongly typed object of some type. So what we say, let's say we have an employee object. So if we say this particular data set or this particular val is data set of employee, then we say this particular object is a data set. But if it is data set of generic object row, then we'll call it data frame. Okay, let's see quickly. So it will open Spark context for us. Let it get open. So one thing is clear, right? Data frame is data set of rows. So let's see quickly here. Now, while this is opening, let me cover this thing in more details. So data frame, there's a case we try to access a column which is not on the table, and the data frame API does not give you compile time error. So this, what compile time error means, let's say we have the table like this, in which we have 4 columns, and we have order status, cust ID, date, and order ID column. And in case of data frame, if I try to select employee ID from this table, it will compile successfully even though employee ID is not in this column, in this table. But it will give error on the runtime that, guys, employee ID is not in this table. So this is called compile time runtime error. So data frame will give you runtime error, right? If you select employee ID from table and employee ID is not in the table, it will give you compile time. It won't compile the program. Like, one more important thing, data frames can be coded in 4 languages, all the 4 languages, Java, Python, Scala, and R. But this is the most important thing. It can only code it in Scala and Java. Why? Now the question arises why? Because data frame cannot work with generic types. Data sets cannot work with generic types, and typed object or the typed, when we talk about Python, what kind of programming language is Python? Dynamically typed. And we need static type here because data sets are strongly typed objects, right? I told you about the catalyzer or optimizer, but we'll cover it later. But data set and data frame both give the functionality of some optimization behind the scene, right? So let's go here. Now, I want to cover data sets in this lecture. I will be covering data frame throughout the next 2 to 3 lectures. But when we talk about data sets are type safe. The benefit is they have schema, they have They give you programming language feature with Scala and Java, and they are lazily evaluated because behind the scene, RDDs are there, obviously, and the serialization I'll cover in two things, right? So when we talk about RDD are low-level coding in which you need to know a bit about coding. You need to tell how to do things, right, and what to think both. RDD's best benefit was compile time safety. If there's some error, it won't compile. DataFrame provides automatic optimization, but it lacks compile time safety. Then people come up with something which is between both RDD and DataFrame, and that's where Datasets comes in picture. So Datasets combine both RDD feature, that is compile time safety, and DataFrame feature, that is SQL automatic optimization. RDD was the feature of Spark 1.0. DataFrame came in Spark 1.3, and Dataset came in 1.6, right? And when we talk about datasets, and this is a very see, when I go to spark.apache.org documents, I found a very good article there. So I'll read it for you guys. Dataset is a strongly typed collection of domain-specific objects that can be transformed in parallel function and relational program. This is the most important thing here. Domain-specific objects. So it means they are not generic objects, right? Each dataset has an untyped view called a data frame, which is a data set of row. So data frame is a data set of row. Operation available on the data sets are divided into transformation and action, obviously, because behind this and everything is RDD. Transformations are the one which will create a new data sets. Actions are the one which will trigger the computation and return results, right? The transformation include map, filter, select, aggregate, group by, and action include count, show. This is something new, don't worry, I'll show you the practical, but count, show, and writing data to the output files. More or less same as RDD, okay? Data sets are lazy, that is computations are only triggered when action is invoked. Same thing applies to RDD. Internally, data set represent a logical plan that describes the computation required to produce the data. When action is invoked, okay. So what is going on behind the scene? We know in RDD what was going on. That DAG was created behind the scene, and then it goes to DAG scheduler, task scheduler, and a lot of things were going on. In case of dataset, what's going on actually? That the same thing is going on different way. So we have two types of plan. One is called logical plan, and one is called physical plan. Okay. So in logical plan, what is going on? Whenever you hit some transformation means what? Filter, flat map, whatever, right? These kind of select, aggregate, group by. It will create a logical plan. Whenever you hit a count, show, or writing data, whenever you hit action, the logical plan will be converted to physical plan. But here somewhere in between, there's optimizer, which will select the best cost-based optimized logical plan and convert that plan into physical plan. This is, I'll cover in a lot of detail, but this is how things work behind the scene. Okay. Data sets are compile time safety. It only supports compile time. Okay, this is the most important thing. So why data sets have only two language support? Because out of Python, R, Scala, and Java, only two languages are compile time safety provider. Okay, it's not interpreted. Okay, so when we talk about, there are two types of languages, right? One which can be compiled, but not in and cannot be interpreted. So Java and Scala are compile type language. R and Python can be interpreted. So data sets are only supported with compile time languages. Okay. Till now we are good. Let's see this thing. Yeah, I want to show you this thing. So I'll go here now. So I'll show you what row objects look like. Okay. So I'll just import something. Perfect. It's imported. And then I'll create a val of row. What I did, I'm creating a val of row. So I have imported row object. Row means generic object, and I'm creating one row with two parameters, with actually two columns, one and hello. But see the magic. What it did, it created row object, and the magic is still not there, sorry. It created row object with two values, one and hello. But now when I go for row one, what it will show me, let me show you. See, this is what I was talking about. What is returns? Any, right? So it means row is a generic object. When I say row 2, it will say 1, sorry, row, how I need to go? Row dot get 1, row dot, 1 second, get 1. It will say any hello, and I will say row 0. It will say 1. Okay. What I'm trying to show you here, that even though I created row object with 1 and hello, in Scala how things works, you know, right? Whenever I say well, my well is equal to hello. What it is doing behind the scene, it will create a hello variable and it will put a string here, right? But when I created a row object and I get one row object, it is giving me anything, any key val, right? It means row are generic in nature. We can assign it anything, and that's where the data frame is a data set of row. I was just explaining you what row means in reality, right? So till now we are clear that data frame is data set of row. Row is something very generic, and if we want a strongly typed data set with some object, domain specific object, then it will become a data set, right? Okay, till now we are very good here, right? We have covered a lot of details in dataset. We have covered what data frame is, and we have covered what dataset is. Okay, now one more important thing. Before Spark 2.0, what is going on, that even though you want to, let's say, what you can do in Spark, right? You can have some Spark context. What Spark context will be doing for you? Spark context will be a entry point for you guys to open the door of the Spark cluster for you guys. It's a main class, right? But if you want to use SQL context, if you want to go for SQL context means if you want to write query, if you want to process data of a structure, if you want to process structured data in form of SQL, you need to create a SQL context. Sorry, it's not written here, it's a Spark context. You need to create SQL context, right? If you want to process data in Hive, you need to create Hive context, right? I haven't covered it because they were not needed as of now. But what I'm trying to tell you here, that in Spark, before Spark 2.0, you need to create separate context to interact with different type of objects or different type of systems. You have Spark context, which will deal with your files. You have SQL context if you need to process your data in terms of SQL. If you have Hive context if you want to process data in Hive. In Spark 2.0, they have introduced a new context or new session, which is called Spark session. And this Spark guy says, guys, going forward, you do not need to worry about creating multiple contexts. What we did something like this. So we created a Spark context. This is your Spark session, sorry. Spark session. And inside this, we have Spark context that we call SC. We have SQL context. And we have Hive context. Now, you just need to create one Spark session and you can access Spark context, SQL context, or Hive context. As simple as that. So they make things more simpler, right? So now the thing is, how do we need to create a Spark session? It's very simple. Let's do it today. In fact, let me explain and I'll copy paste. So you need to import a Spark session, org.apache sql.spark session. Into Spark session, you need to call builder function. Builder function will take multiple parameters, but the most important parameter is app name, right? And then the master as well you can produce, right? If you want to use Hive context in a Spark session, you need to use enable Hive support. And then at the end, you will say get or create. Now, what is get or create? Get or see, we know one thing. We know one thing, that in any application, we can have only one Spark context, right? So what get and create is doing for you guys, if Spark context is already there, don't create it, get it. If it's not there, create it. But don't create duplicate Spark context, because that's not supported. You can only have one Spark session, one Spark context, one Hive context, one SQL context in your session. And that's where get or create will come in picture, right? Now the thing is, I told you, right, how to access Spark context from a Spark session. It's very simple. You have created your Spark context well. Now from this, it's very simple. Let's say you need to create SC, right? So you'll say SC, well, SC is equal to Spark underscore context dot what we need to get? We need to get Spark context. We need to get Spark context. Simple, right? So we'll say Spark underscore context. And now going forward, SC is created for you in like this, right? This is how things work. And this is how Spark 2.0 will give you a lot of functionality. Let's do it quickly. Let me copy paste this thing. So what I'll do, I'll go here. I'll say new Scala object, and I'll say Spark session practice simple. I'll say finish. And we know that if we don't want to import the main class, we'll say extends app. We know this thing, right? And now let's do one thing. Import is there, Control X, and let's do this thing. So what we did, okay, so we have created a Spark session with this Spark well underscore SC. Let's remove this if it's not. Perfect. Okay. So we'll name it SC just for a time being, and we'll say print SC. Okay, and let's run it. So what did we do? What I'm trying to show you here, see, behind the scene, everything is same. Behind the scene, everything is same. So what I'm doing, I did here, I created a Spark session, right? And I'm printing Spark context from Spark session. Wait, something is wrong. 1 second. Let's do, basically I run from here, right? So it ran other configuration. I need to run this application from here. Run as Scala application. Actually, it ran this test.scala, right? But I need to run a Spark session.scala, so I need to change the context. What happened here? Master URL. Okay. I missed one thing. Dot master No, 1 second. I missed one thing here, configuration. Just 1 second, guys. Yeah, this one. So I have to, I told you guys, but I missed that point. I need to set the master. So I'll say set master, and I'll say local, and use all my cores, all my PC's cores. And I'll say here space remove. 1 second. I'll say Control X, Control V, and now see if it is working. But it says set master. Okay, this is the problem actually. This is the problem from the copy paste. I don't want high support. I'll say get and create. Dot master, I'm not sure what's not working. 1 second, guys, sorry. So set master is yarn. Okay, let's see one thing. Okay, 1 second. So what is saying that do one thing, context, and this is good, and Control Z, Control X, so this thing, and remove this part. So what I'm doing here, I have done spark conf, my spark conf, set name, set master, and then this is how Spark context works. Now, ideally it should work. Spark session.builder. Let's do one by one. So we'll say let's remove this as well. So we'll say, well, let's say SS is equal to Spark session dot builder. Okay, builder dot app name, and I'll say test, then I'll say dot, then I'll say master, okay, and I'll say local star, and then close it, then I'll say dot, and I'll say get and create, and then I'll say val sc is equal to ss dot spark context, and then I'll say print sc, let's see, and I'll say run and Scala application. Let's see. It's just a copy paste thing, guys. So spaces came in between. I just write the code again. Local cannot parse master URL. So let's say local run a Scala application. So I'm just trying to create a Spark session. I'm not sure why it's not working. Let's see quickly. Same thing. What is going on? 1 second, guys. So it says, okay, sorry, my bad actually. So it will say local and star. Now it should work. Basically, it's a case sensitive. Scala application. Perfect, it worked, right? So what it says, it gave us Spark context. Okay, so some mistakes what I did, copy pasting, when I copy pasted, space came here like this, so I removed the space. The other mistake is the local should be in a small case, I was using the capital case, and then everything was same. So to create this Spark session, you need to import sql.spark session, then you need to create some variable. This variable can be anything. Then from the Spark session, you need to call the builder object, right? What this builder object will do, this builder object will create the Spark session for you guys with these particular configurations. Application name test and master as local star. What master local star means, use all the codes from a local machine. And then get or create means, I told you that get or create means it can only create one Spark session for one application. Now this is how you need to go for a Spark context from a Spark session. So let's say this is how Spark context work. Let's say if you want to go for SQL context, you'll say just, let's say SQL is equal to ss dot SQL context, somewhere here it should be, right? So you can have SQL context like this. Well, Hive context is equal to ss dot. Okay, one Hive context is not coming because I need to go for enable Hive create here. So when we go here, it will say enable Hive support, right? Let's see if this is working. So we'll say dot enable Hive support, and let's say here ss dot Hive. It's not coming. Anyways, this is how it works. Okay, so Hive context not coming, but we do not need to worry about it as of now. So we'll see this later. But what I was explaining it to you guys, that in Spark 2.0, they have created a Spark session, and inside Spark session, they have put all the context for us, right? So if somebody asks you what is Spark session, you will say Spark session was introduced in 2.0, and it's a new entry point that essentially replaced both SQL context, Hive context, and will give immediate access to Spark context. Okay. So in order to create a Spark session, you need to go for this builder object into the Spark session. You need to give app name. You need to give master, and then that work for you. Okay. So this is important. Let's play around, because since we have a Spark session now, let's play around how to do it. Okay. So one thing. So we have three things now. First thing is RDD. Second thing is DataFrame. Third thing is Datasets. Right? Now, the thing is, if we want to convert some RDD to DataFrame, how it can be done? We need to give some structure to it, right? And structure can be given multiple ways. The most easy way to give structure to something is case class. Okay, so the most easiest way to give structure to your RDD or to some data is case class. So what exactly is case class? Case class is just a normal Scala class, but it is good kind to create immutable objects, because we don't want to change the schema again. So this is how it works. So we'll create a case class, and let's do it. So I'll say, I'll copy it here. I'll say create my case class. Okay. And then when we want to convert between, let's say if I want to convert data frame to data sets, right? So this thing is not supported by default. We need to import this important thing. So we'll say import ss. So what I'm showing you here, that this implicit is used to convert data frame to data sets or data set to data frame. So there is an easy transformation which can change data frame to data set or dataset to DataFrame, but we need to import implicit from Spark session, right? So this is good. Now after this, we need to do, okay, now one more important thing. So let's say I have one order.txt file. Okay, if I need to read this CSV file, how I need to read it? Before I jump there into a lot of details, let's first read this file. So what I'll say, well, orders is equal to ss.read, right? ss.read dot, what I need to read? CSV file. Perfect. So I'll say CSV file. What is the path? It's just it is in my local into temp. So what I'll say, tmp orders, right? So what now, when I hover over here, it's a data frame. So by default, it created data frame for me. So if I need to see the data of the data frame, I need to hit some action. So I'll say orders dot, these are few of the transformation and action what I can do, right? So let's go one by one. So if I want to convert this into RDD, I can use two RDD function, but we'll do it later. Let's see the data, how it looks like first, okay? Dot show, and let's run it again. So run configuration, and what it says, run. So what it is doing, it is reading some file for me, and then it is writing the data. Let's do one more thing till the time it's running. Let's copy these two lines just to prevent, let's say if we don't want this too much error, right? So just copy this thing and just copy this thing here. So what I'm doing, that I don't want this all things here. So what it says, that path does not exist, temp orders.txt. So I should give here orders.txt, right? Let's run it again. Run as Scala application. So now the other stupid information logs are gone. So it will only give us the details what we want to see. Okay, let's see. Okay, perfect. See how this data is looking to you guys. And when I go here in the tested Scala, I don't want to run it again, but you remember, right? The data was not structured. That data was not structured. Now what this data frame did for me, it did created the data, right, into some structured way, and it tried to assign some schema, right? But when we see here, it assigns some column names, C1, C2, C2, C3 here, right? But in ideal world, we want the header to be taken from the file, right? So let's do one thing, dot option option should be here. 1 second. This one, but it's not coming. Dot option is equal to true. So if I do here, if I do like this, Controls Shift O. One second. Control X. So Spark dot SQL context dot read spark dot. So 1 second. So we'll say SQL dot read dot CSV, and let's paste it here. One second. Let's see. I'm not sure what's not working. Control Z. So SS dot well orders equal to orders 1 dot CSV and dot option. The option is coming now. So I'll explain it to you why it's not coming, why it was not coming. Control V. And let's remove this. And now dot load and then some path. Okay, so I'll say here temp orders.txt in double quotes, and I'll say remove this and run it. I'll explain it to you when it runs. So what I'm doing here, so what we have seen that order.txt has some header into it, but it was reading that row as data, and it was giving that C1, C2, C3, C4 by default the column names, right? What I was asking this guy that, okay, please give me orders.txt path does not exist. One second. Not sure what's not working. Just 1 second, okay? Give me 2 minutes. Control X dot load and this should work. I'm not sure. Dot. Okay, let's see one thing. Properties. Anyways, what it is asking, give the absolute path. Okay, so I'll Control C here, cancel. Control Z. Perfect. Sorry. Dot load and Control V. Okay, so this one, this one, let's see, and let's run it. Let's see. 1 second. Yeah, it worked. So basically, some stupid issues. I'm not sure what it was. So it is asking me for the absolute path. Okay, so load will always take the absolute path, and then when you works in Windows, when you use single quotes, then it use single backslash as escape characters. To escape the escape character, you need to put two this, right? Now what I need to show you here, what I say, dot option dot header is equal to true. So when I go here, now see the magic. So it gives me all the orders with header, right? Now let's do one thing. Since I told you that when we talk about data frame, it has data types and a schema to it, right? And data types and data name of the columns to it. Let's say orders dot print schema. I want to see the schema now. So what I'll say here, run as Scala application. The best part about working in Linux is these things, double backslashes are gone. Like we do not need to worry about all those things, right? It's just with Windows. So what I'm showing you here now, that it will show us the schema as well. Okay. Now, most important thing, right? What it did, it did figured out this schema for us, right? But what it says, every schema is a string, right? Let's solve this problem. What we'll say, that infer schema is equal to true. I'll explain it to you, but let's put that here and let's run it again. Run as Scala application. So right now we read the CSV file, right? To read the CSV file, we need to give the full path, and then we tell the Spark session that header is equal to true. And now we are asking this Spark session, guys, please infer the schema from the data type, from the data which is in the file. So let's see now. Perfect. So what it did, see now, previously everything was a string. Now when we asked it to see the schema from the data, and when we see the data, what Spark program ideally did for us, it revolved around all the data, iterated around all the data, and see the data type from his code, from its code, it figured out the data type for us, right? So the order ID was integer, or date is timestamp, integer, and string. Now let's do one thing. One last thing for the today, right? Let's do one thing. Let's put this line. And why I don't need to put this line? When I go for, right now, when I go for localhost 4040, it's still running. Anyways, let's do one thing. Let me remove this, right? And when I run it again, what I'm trying to show you guys, one more important thing. So it will obviously give me all the logs now, and I need to find out on which port this program is running. Okay, so this is the last thing for today. So we'll say it reached till 4047. Okay, so it reached till 4047. But now the most important thing, let it run. When I go to port 4047, everything is done, right? And the application has been stopped, terminated. Now, if I go for port 47, it won't be there. It won't be there, right? Because the Spark UI is only valid till the program is running for you, right? And to keep the program running, what I was doing, I was putting this line. So it will wait for me till the time I won't terminate it manually, right? Let's run it now. And I'll show you one more important thing, last topic for today. So behind the scene, everything was RDD, right? So some execution plan is taking place, some logical plan was taking place when I hit the action, some logical plan is converted to the physical plan, but everything behind the scene is if we're starting, perfect. Okay, so let's run 47. See now. So I told you one thing yesterday, number of jobs is equal to number of actions, right? So what it did, it created 3 jobs for us. Now what are these 3 jobs? Let's see quickly. First job is reading the file. The second job is inferring the schema. And third job is show the data. Now, one thing is very clear, although Spark is doing a lot of work in inferring the schema, but it's not always beneficial if you have millions of rows, because it will iterate to all the rows, then it will infer the schema, right? So if we know the schema of the file before we run the program, this option is not beneficial. So this is how it runs, right? Let's go here and show the DAG visualization. Okay, see here. So what it is doing the same thing behind the scene. Everything is RDD. It converted our programs to RDD as I was explaining it to you. So it scanned the RDD, it mapped the partition, then it did some again mapping, and it created the map partition again and again. So what I was trying to show you here, that everything behind the scene is an RDD. Okay, let's do one more thing. When we go here, so this is stage, and yeah, this is what I was showing you guys. So when we see, so what we are talking about here, we are talking about data frames. We are talking about data frames. And when we talk about data frames, data frame is data set of row, and data set of row is generic objects, right? So what this guy is doing here, this is converting those generic objects into bytes, deserialized, so that we can read them, right? And at the end, it is doing some map partition, and it's in one stage. So everything is same as we discussed yesterday in the RDD session, right? So number of jobs is equal to number of actions, then number of tasks is equal to number of partitions, and number of stages is equal to number of byte transformations. Since we haven't used any byte transformation here, it's just one stage. Okay, we'll discuss this thing in a lot of detail tomorrow, but that's all for today, guys.